All right, welcome to the Explainer. Today, we're going to put a tiny piece of code under the microscope. And you might be thinking, why? Well, believe it or not, these few lines teach some of the biggest lessons you'll ever learn in professional software engineering. You hear this quote all the time in software engineering, and you know what? It's perfectly illustrated by the little script we're about to break down. It really all boils down to one powerful idea. If you want to build things that last, you've got to keep them simple. Now, when you first look at this script, it might seem like nothing special, right? Kind of like the tip of the iceberg. But what's lurking underneath, that's where the magic is. It's just packed with the kinds of good habits and design principles that really separate the pros from the beginners. Okay, so let's get to it. Time to put our specimen on the table. But before we dive into the code itself, let's make sure we're all on the same page about what it's trying to do. It's actually a pretty simple goal. So what this script does is basically a 4-step transformation. It starts with some messy, raw text, then it cleans it all up to get just the words. After that, it tallies up how many times each word shows up. And finally, it spits out that info as a nice, clean, sorted list. Sounds simple, right? But the how, the how is what really matters here. And here we have it, the whole thing, the entire program. And it's less than 20 lines of code. Just take a second to look at that. Now, let's break it down piece by piece and really uncover the super smart decisions that are hidden in plain sight. All right, let's start the analysis. We're going to see how this thing is built, and we'll start right at the top with the very first lines of the script. So the script kicks off by importing two really useful tools from Python's standard library, counter and re. And trust me, these two are going to do all the heavy lifting for us. And right away, we hit our first huge lesson. Great programmers, they don't write code they don't have to. Think about what you don't see here. There are no manual loops for counting stuff. There's no custom code to sort anything. Instead, this script just leans on these built-in, highly optimized modules. And that's not just a shortcut. It's a fundamental principle of smart, efficient engineering. Okay, next up, you'll notice that all the core logic, the real work of the program, it's all neatly wrapped up inside one single clean function called word frequency. And this is just a brilliant illustration of a super important principle called separation of concerns. Isn't that a great name for it? See, by putting all that logic in a function, it's totally separate from where the text comes from and how the results get printed out at the end. This makes that core logic reusable, and it's way easier to test. This isn't just about making your code look pretty. This is about structural discipline. Okay, now check out this line. I mean, seriously, look at it. This single line of code is just unbelievably efficient. It's doing two totally critical things at the exact same time. It's normalizing the text, and it's extracting the words. First off, it normalizes the text using .lowercase. So why does that matter? Well, Python is case sensitive. Without this step, it would see simple with a capital S and simple with a lowercase s as two totally different words. And that would, of course, make our final counts completely wrong. And second, it uses something called a regular expression to pull out only the words, and to do it with real precision. This pattern, it's looking for a sequence of letters, and it's anchored by what's called a word boundary. Basically, that's just the space between a word character and something that's not a word character, like a space or a comma. This is so much more accurate than just trying to split the text by spaces. So once we have our nice, clean list of words, what's next? What do we do? Well, instead of writing a clunky loop to manually count them all up, the script uses a specialized tool that's built for exactly this job. It's called a counter. And this right here is the magic of using the right tool for the job. You just hand counter a list of items. In our case, all the words on the left, and bam! It instantly gives you back this special object that's already tallied up the frequency of every single unique word. No loops, no manual counting, it's just the perfect tool. All right, this next bit of code, if name equals a main. I know, it might look a little weird if you're new to Python, but you have to trust me on this one. Seeing this line is one of the biggest clues that you're looking at code written by a mature, experienced developer. This little thing is called a main guard, and what it does is pretty cool. It lets the file have two different personalities. So the code tucked inside this if block, it will only run when you execute the file directly from your terminal. But, and this is the key, if you import this file into another bigger program, that block gets completely ignored. This is what makes your code incredibly flexible and reusable. It's a game changer. Okay, so we've dissected all the individual parts. Now it's time to zoom back out. Let's pull all these observations together and really look at the amazing best practices this tiny little script is quietly teaching us. And here they are, the key takeaways. First, normalize your data before you do anything with it. Second, isolate your core logic inside functions. Third, have your functions return data. Don't just print stuff out from inside them. Fourth, use the powerful tools that are already built into the language. And finally, separate your reusable code from the code that's just there to run the script. Look, these aren't just little rules for a tiny script. These are the foundational principles for building solid, scalable software, period. So, once you really let these foundational principles sink in, the next question just naturally pops into your head. Okay, this is great, but how do we scale this thing up? For example, our current script, it only handles simple English letters. So what happens when you run into words from other languages with accents and different characters? Or what about hyphenated terms like state of the art? How would you have to change that pattern to handle more complex text like that? And then there's performance. Our script reads the entire text into memory all at once. That's totally fine for a little bit of text, but what if you're trying to process a file that's gigabytes in size? The whole thing would crash. What changes would you need to make so you could process that massive amount of text without running out of memory? Would you have to, I don't know, stream the data somehow? You see, these are the exact kinds of questions that kick off those big system scaling conversations. But what's so important to realize here is that they all start from the exact same solid foundation that we just analyzed in this little script. And that, right there, brings us to the single most important takeaway from this whole thing. Good habits scale. It's really that simple. The discipline you practice, the structure you build, the design decisions you make on the tiniest little programs, those are the very same things that will make or break you when you're building the largest, most complicated systems you can imagine. And that is the real lesson here.